16,000 RPM and 96 inches a minute is a little too fast in 6063. But maybe not. I forgot to turn on the Trico lubricant coolant system. You can see, we'll show you the videos right now. You can see when I cut the first side, the ones where the holes went okay, I did these slower, 12,000. You can see the little drops. You can hear the Trico going and it blowing stuff. I forgot to turn it on. I did change setups, forgot to turn it on, and it had enough residual lubricant, this super $120 a gallon Trico MD7. It did this cut fine, and I went fast. I didn't do it in 2 swipes like this side. I did it in 1. But by the time it got to the hole, it was too dry, and it's gummed up the end mill. Let's look at some pictures of the end mill. Here's one side. Ouch. Here's the other side. Okay, not total loss. You put them in sodium chloride oven cleaner, easy off, or Drano, and it'll dissolve the alumina off and leave the carbide, and hopefully I haven't ruined it. I've got a second one when I bought the Avid. The other mistake that became apparent is there's a 1/10 of an inch offset between the 2 sides. And I'm like, but first time I just used the kind of a machinist's ruler and measured, okay, and tried to get. This time I used a little magnet setup. You can check it out. A little magnet setup so I could slide it back. My realization was the back side, since I only slot the one side, I don't cut this off yet. And then when I turn it this way, so if I did a stop at the back low enough so it wouldn't get in the way of the mill, then when I turned it this way, because this part was still attached, even with a big slot in it, it would stop. And when it came out exactly 100 thousandths, exactly a 1/10 of an inch, that was the cut I made on the front. We'll show you what I did wrong there. For now, let's go look at the videos. I'll put speeds and feeds alongside what it's doing, and you can see and listen to how it's going, okay? Let's take a look. All right, pretty informative. First thing, let's go and, oh, you should have noticed, right? I'm pretty sure I did not turn on the lubricant. And the way this thing loaded up, and those NEMA 34 motors that I ordered, the bigger motors, you can tell they're powerful. This thing was really humming, is bending the whole setup. Thankfully, I didn't break the tool, so we got away with it this time. So the first problem is this offset problem. Why the heck is going on? Operator error. You know, what did I touch last? If you go here, these 2 tabs always get me confused. The feature tab here and the operations tab here. And I had a lot of struggling with Solidworks / CAMWorks. Changing features. We'll go over what I did, and it ended up clobbering my speeds and feeds once. It must have overwritten that, say, oh, well, you did feature recognition, or no, you did operation plan, generate operation plan. Don't do feature recognition. It'll put drills in and everything I don't want. So anyway, here in the feature tab, if you look at, I named the setups to remind me what's going on. Flange rightward, okay, it comes down here. This is the way it would be, I can never get this right. Oh my God. I can't even see, let's see, how is it? Okay, the ellipse was in the front, yeah. So like this. So there you see the arrow coming down. Flange leftward, that means I change the vise setup to do like this. And it's coming down, but it doesn't tell you the origins. You got to go and get here, and you can, let's close it so it's not so confusing. Flange rightward, I set the origin where the stock was going to be, right? If you highlight the stock manager, that's the stock, because that's where you find part 0. I got a tool probe with this Avid. I had to put a plastic bag down because I'm doing metal and it's meant for wood. So I got to make a maybe the first real machining project making useful parts will be a plastic base for that tool probe. So I can set it on metal and it won't say it's touched. So I put a plastic bag down, put the probe on top, found 0, and all that went great. And then I'm saying, well, what did I do wrong? Well, look at where I put the leftward. It's up against the part. It's not up against. I knew enough, and I had to do all kinds of head scratching. It's like, okay, when I'm doing this surface, that means the fixed jaw is against this surface, and it's pointing up like this, right? Fixed jaw is up against this surface. So, you know, that's that little corner of the stock. That's what I want to find. When it's repositioned like this, well, now the fixed jaw is here, so you don't want this corner to be part 0 anymore. You want it to be straight above the fixed jaw, like it was, but you want it where the stock starts. So not too big a tear up. Get here. Let's move this out so you can see what's going on. By hand, I move this up, so it's -Z because Z is downwards in this. See the arrow pointing down, the little red arrow pointing down for Z. So I did that. 128, I think, was the stock thickness. For some reason, it doesn't show the significant digits in this. For Y, the fix is pretty simple, right? We want to come out. Here, let's get it set so we can see. So since Y positive, it's hard to see this green arrow, but it's pointing towards the back, the way the mill is, right? You got to match these axes to what's positive and negative and the directions in your mill. So here I just went Y. I knew I decked off 0.1, so 0.1, go there. Oops, minus 0.1. Minus 0.1. There. So now this, say OK. See, new tool pass. Bang. So this should solve that problem. You can see here's the one. Here's the other, and now they're both 1/10 of an inch. So that fixed that. So let's go through, look at pictures, go to the operations. What I changed, this is where we want to be. Back edge. I let it do its thing with 2 cuts. I already adjusted the first part, first chips. So it would go about halfway down in the first cut, all the way through on the second. That went just dandy. Let's double click and see if we can get speeds and feeds. Let's look at a picture of that first. So the surface, I mean, I'm really pleased. The hole looks great, and I sped it up. Okay, you can see that in the videos. We won't dwell on this. But you can say in feeds and speeds, I sped it up to 12,000 instead of, I think, 10. And then I wanted to take 2/1000ths of an inch chip load per tooth. So I think I ended up typing here, and it gives you the 48 inches a minute feed rate. It's pretty respectable. Okay, so that's that one. Ooh, don't close it here. I'll be chasing this dialog box. If I close it in this screen, it goes to a non-existent monitor. The hole. I said, look at the hole. Look at the end last time. Now we're going to look at the hole. So here's the hole. It, once again, 12,000 RPM, 2/1000ths of an inch chip load, 48 inches per minute. The picture of the hole looks pretty good. I'm pretty happy with that. Let's see, what else did I do? No, this one, pretty much, I just sped it up a little from the way it was in the first chips. ellipse, same thing. I just want to show you, in case you're curious, all these other little tabs. You know, you can stop the video and see where it's set. Same thing, 12,000, 2,000ths chip load, 48 inches a minute. All the stuff that I wrote over the other videos. Then this one, I don't think I sped it up towards the front edge. I let it do it in 2 whacks. And did I double click? Probably not. No, I double clicked. And here, oh, I did. I got a little bit friskier on this front one. Here's a picture of it. Okay, so it came out, let's look. This is the fronts by the ellipse. It came out really nice. It's got a little ding where it went through the thicker stock, but it looks beautiful. But of course I had the coolant turned on. I had the micro drop Trico coolant working on this one. And so now I kept it at 12,000s, but said, let's take 3,000s per chip load per tooth. And so that ran at 72 inches per minute. So we're really jamming now, as Frank Zappa would say. Okay. Then the next setup, as far as we got, now I forgot to turn on the coolant. So we'll turn this, we'll go here. Here's the stock in the back. There I didn't do 2 cuts, I just did 1. And it came out pretty darn good while there was just the residual coolant from the earlier side, the earlier setup. Here I said, let's go 16,000 RPM and down to that point, you know, 0.002, the 2,000ths of an inch per tooth, 64 inches a minute. That's hauling. That's doing pretty good. And it did, you know, check out the picture. It worked out pretty good. Close this. Oh, that's the other thing. I did 2 whacks. Last time, when that big chunk got cut off of this thing, as it cut through and freed that big hangover, like almost an inch, it kind of dinged up towards the corner. So this time I did it in 2 operations. I did the cut stock operation here, so I shouldn't, that picture really wasn't for this. Then watch it hop when I hit back edge. Well, you can actually see it, right? So I left 20,000ths. Let's go show you that again. Sorry to be sloppy. On the contour up here, I left an allowance of 20,000ths. So then the big piece fell off and any kind of interference with the mill and imperfections happened there. Then here's the real back edge, and here's the picture for that back edge. Like I say, I'm pretty pleased with the way that came out. And feeds and speeds, 16,000, 2/10. So things, it got away with it there with no coolant, but by the time it hit the hole, here's the hole, ouch, 16,000, I went up 3, so 96, but by then without the coolant, it was hosed. So you can see the mill just loaded up, and everything after that was death spiral. Here's the ellipse. Oh, because the first chips, I left the centers in. I did a contour, a finish around the outside. That's bad practice. You're not supposed to leave a chunk in the middle that can get in the flutes and maybe break an end mill. So this time I redefined them as rough. You got to go in the feature tree. This is where I clobbered my own settings and things went wrong. I'm not confident at all using Solidworks CAM. It always seems to be fighting me. But I changed them to roughing operations where it will actually make sure all the material's gone, instead of leaving a little plug in the center of the hole and a little ellipse in the center of the ellipse. So we got that sussed out. The ellipse, I think it's the same, yeah, 3,000ths, 96 inches, 16,000. Here's a picture. Tore it up pretty good, didn't I? Don't ask me why I waited. I saw the whole thing bending when it did the hole. I should have hit stop while it was up in the air, but that's life. And then I can't show you this front edge where I never got here, right? I e-stopped it before then. But here I said, well, let's really go like the Destiny tools that I talked to them, by the way. I'm gonna buy them. I refuse to accept gifts. I think that compromises my objectivity. So I'm going to buy some Destiny end mills, and they say you can push them 4 thousandths to 5 thousandths, a 1/4 inch end mill for chip load, and almost unlimited speeds. So we're going to play with those. I'll talk to the fellow Monday. There's a Florida rep I got a hold of. So this is going 128 inches a minute. This machine only does 200. I mean, this is getting into a rapid zone. Same 16,000. So we'll see. Now that I've fixed this, I'm going to save it as a different name, save it as a third chips, I guess. And we'll do that next and see, with remembering this time to put on the coolant, will this thing hog these 2 holes at those kind of speeds and feeds? And I got a new end mill to try. So that's a perfect opportunity to see if I cause some problems. All right. So until then, let me see. Anything else I wanted to show? The operations, speeds and feeds with the pictures. Yeah, I'm going to stick with these speeds and feeds. So that's the CAM for today. Good luck with your CAM projects. See you next time.